Now we'd like to start to understand this pattern in a little more depth. Why is the central maximum wider than the other ones? And why do the later maxima become dimmer and dimmer? The central maximum is wider because where you would expect a minimum at m equals 0, there is none. A sine theta equals m lambda will give me a minimum, either to the top or to the bottom. You would think a sine theta equals 0 would be a case where we would get a minimum. But in fact, if they're all going to the center here, then essentially all of the path lengths are the same. And that is the strongest maximum. So a sine theta equals 0 is not a minimum. If that were a minimum, then the central maximum would be split into two maxima of equal size. Instead, we get one maximum that's twice as wide as the others. To understand the dimming, it's useful to look at the phase difference between different rays based on, or in terms of angles. So the phase difference as an angle in radians is just 2 pi divided by the wavelength times the path length difference. Path length difference over the wavelength is the number of cycles of difference, and then we multiply it by 2 pi radians for a cycle. So if we're talking about 2 points along a slit that are separated by a distance delta x, then the path length difference is just delta x times the sine of theta, and we multiply that by 2 pi over lambda to get the phase angle difference. Now let's imagine what happens as those differences get bigger. When theta equals 0, the phase for all of the different rays of light anywhere along the slit is exactly the same. All of these points have the same phase to reach the middle here. So all of the phasors line up in a straight line. They give a large total, a large maximum E. As these phasors start to curve, the angle they curve through increases depending on how far away the next ray is. In other words, they're going to form a nice smooth curve. In fact, since it's totally open, each one of these phasors should be infinitesimally small, and this should be a perfectly smooth curve. And then the final angle here would just be this phase angle with delta x equal to a, the slit width. Now as that curve increases, as they become farther and farther apart, instead of being the straight line that's just equal to the sum of all of those individual phasors, it's the chord across the arc. And the chord across the arc is always going to be smaller than the total length of the arc. The total length of this arc is still what it always was. But now, the chord, the sum, the vector sum, is smaller. Eventually, we're going to get to the point where the total angle, when delta x equals a, is going to be 2 pi. And that means these different phasors will wrap up, add up to on top of each other, and add to 0. That will be our first minimum. Now, as we continue to turn more, as we get a larger and larger value of sine theta, these phasors will turn further and further, and will start to wrap beyond one full cycle. So this has gone more than one full cycle, which you'll notice means that the phasor has started to get large again. It will reach some maximum value in here. It's actually not simple to figure out exactly where, but we assume it's roughly halfway between the minima. We'll eventually reach a maximum value, but because now, instead of being the line straight across, it's a circle that wraps around a couple of times, or 1.5 times, it turns out that this total has to be quite a bit smaller than this one. In other words, the new maximum to the side is quite a bit dimmer than the central maximum. If I wrap around again, when I get to the point that the total phase is 2 pi, in other words, the total phase difference, or total path length difference from the top and bottom of my slit is 2 wavelengths, this will again add up to 0. As it bends further, I will get another maximum, but it will be a smaller loop, and so it will be a smaller height. In fact, you would expect that that total electric field would be inversely proportional to the number of loops we make. So we would expect it to go like 1 over the number of loops m. And since the intensity is proportional to the electric field squared, we would expect the intensity to go like 1 over the maximum, how many maxima out we are squared. 1 over the number of loops squared.